Hey everybody, this is Mr. Conyer, and this is my series, Easy as ABC. When you have a trinomial standard form, you're given A, B, and C. A is 1, B is -2, and C is -8. Our leading coefficient is 1. The formula that we're dealing with today deals with when the leading coefficient is 1. So I'm going to use completing the square to change this from standard form to vertex form. Once again, A is 1, B is -2, and C is -8. And guess what? We're going to change the vertex form. It's going to take less than 30 seconds. So here's our formula. This is going to change this to vertex form. The formula we're going to use to change the vertex form is x plus half of b in the parentheses squared plus c minus half of b squared. We must use half of b twice. So we're going to change from standard form to vertex form in less than 30 seconds. So let's take a look at this. Here is my trinomial right here. Now the trinomial is once again x squared minus 2x minus 8. So half of b, half of -2, well that would be -1. So I have here x minus 1 squared. Now that means our horizontal movement is 1 unit to the right. What you talking about, Willis? We're talking about this right here. X minus 1 equals 0. Plus 1 plus 1. That means your horizontal movement is 1 unit to the right. So if we're having the vertex, it's going to be plus 1 for your vertex. Solve for x and you get that horizontal movement. That is your horizontal. Don't mind the handwriting. I'm a math teacher, and that's my handwriting. That's the best I can do. So there's my horizontal movement, plus 1. Now, to get our other part, we are going to do c minus half of b squared. So my c is -8. I'm doing minus, but I'm doing -1 squared. Now you remember -1, negative times -1 will give us a +1, but we're subtracting, so it ends up -8 minus 1, which will give me -9, which is my vertical movement right there, -9. That means we're going down 9 units, 9 spaces. It's going down 9. My vertex is at 1, -9. So if I have vertex form, I have x minus 1 squared minus 9. That would be vertex form. X minus 1 minus 9. Now, I'm going to prove it by graphing. I'm going to prove. Now, I'm going to get this out right here. So, remember, we go back standard form. Letter C is the y-intercept. So the y-intercept is at -8. So I start right here. I'm going to start graphing. Let me start at -8 because that's the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. That would be my y-intercept right there. That's the y-intercept. Now, we said the vertex was located at 1, -9. Look at that right there. I'm putting the axis of symmetry right there. The vertex is at 1, -9. That means using symmetry. I know that is a point on the parabola. Now I'm going to find the roots. If you go from the vertex 3 to the right, 1, 2, 3, then you need to go up 9 because 3 squared is 9. Up 9, whoop, there's the root. Let me go 3 left, 3 left. 3 squared is also 9. So those are my roots. So right now I have enough to make a parabola. My vertex is at 1, -9. I got a root here at 4, 0. I have a root here at -2, 0. Those are the roots. And I'm going to make my little parabola. My handwriting is not the best, but it gets the job done. There you go. There's your parabola with the vertex at 1, -9. The y-intercept is located at 0, -8. And we have roots at -2, 0, and 4, 0. And we have vertex form. My vertex form was x minus 1 squared minus 9. That is vertex form.